Everyone, so here we are to learn the topic scheduling, in which the first topic we'll learn is first come first serve, that is Fcfs. Now let me very well clarify you, there are 5 terms that you need to very well understand before understanding any kind of scheduling, and that is arrival time, burst time, turnaround time, waiting time and completion time. So what is arrival time? Arrival time is the time when the process have actually arrived. What is burst time? Burst time is the time for which the process will get executed. Turnaround time, it's very clear. Turnaround time is the total time spent by the process in the system. What is waiting time? Waiting time is the time for which the process waits before being serviced. What is completion time? So now completion time is the time at which the process gets completed. Now I'll discuss you with the 2 more formulas which are very much important and related with turnaround time and waiting time and burst time, and these are turnaround time minus burst time equals to waiting time, and also turnaround time equals to waiting time plus burst time. Here is another formula, and that is turnaround time equals to complete time minus arrival time. These formulas will be very useful for you to solve any kind of scheduling algorithm. So here we'll next discuss the example related to first come first serve. So here is the given example in which there are 4 processes P1, P2, P3, P4, and we have considered the arrival time as 0, 1, 2, 3 and burst time as 2, 1, 3, 2. So in Fcfs, one thing is the criteria, and that is arrival time. The process which has arrived first, that will be executed first. So for any kind of scheduling, we'll first calculate the Gantt chart in order to complete what? In order to complete the completion time. So Gantt chart, which process arrived first? So process P1 has arrived first at 0 second, and for how many seconds it will get executed? It's burst time. So for 2 seconds. So from P1 it will get executed till 2 seconds. Again P2. After that P2 has arrived. After that P3 has arrived. After that P4 has arrived. So we have sequentially numbered all the processes, and P2 will be executed for how many minutes or seconds or milliseconds, whatever will be under consideration. It will be for 1. So 2 plus 1 is 3. Now for P3, for how many seconds? It's for 3 seconds. So 3 plus 3 is 6. Now P4, for how many seconds it will get executed? For 2 seconds. So 6 plus 2, 8. Now we can very well see that P1 gets completed at 2 seconds, P2 gets completed at 3 seconds, P3 gets completed at 6 seconds. So you are going to write it, P3 gets completion time 2, 3, 6 and P4 gets completed at 8 seconds. Okay. Now there are 2 more formulas that you need to very well consider, that I told you before. That is turnaround time is what? Complete time minus arrival time. So where are the column of the complete time? So complete time minus arrival time is turnaround time 2. Okay, again 3 minus 1 is 2. Again 6 minus 2 is 4, and 3 minus 8 minus 3 is 5. So here we calculate the turnaround time, and after this we need to calculate the waiting time. So for waiting time, what we need to do? Turnaround time minus burst time. So what is turnaround time? We calculated last, that is 2, and what is burst time? 2. So it's 0. Again turnaround time and burst time. 2 minus 1 is 1, 4 minus 3 is 1, 5 minus 2 is 3. Now after calculating all of these, we need to calculate what? Average waiting time. So average is same as we do in maths. Average waiting time is, you need to add up all and divide it by the number of processes. So what is first? 0, after that 1, after that 1, after that 3. Add it all and divide it by how many numbers are there? 1, 2, 3, 4. So you can convert it to decimal 2 for average waiting time. This way we can, for average turnaround time, you can compute it same way by adding 2, then 2, then 4, then 5 and dividing it by 4, and it's 13 by 4. You can convert it to decimal 2. So in next video we'll learn about SJF. Very thank you. If you do like my video, please do subscribe my channel Educating World. Thank you.